Okay, I'm going to re-record the run-through for this exam from 2019. It's already on YouTube, but there was a problem with the camera. I did it with a visualizer and the autofocus wasn't working, so the quality is just not good enough. So I'm going to try and go through this to allow students to look through their answers. I'll do it as quickly as possible without missing out on any detail. Okay, so this is from the first year of the Pearson Edexcel Physics International AS level exam, which is the first year of the A level, Unit 2, Waves and Electricity, and my students are doing this topic right now. They've done electricity and they're finishing off the year with waves. So this will help them with their preparation for next year. Okay, so the International A level always starts with 10 multiple choice questions, and here is the first one is to do with units of electricity, the EMF. Okay, so these exams are perfect for students preparing for the normal Edexcel A level because for the linear A level, this is the same content covered, but there are fewer practice exams available because obviously the linear only does exams in June, whereas the modular does exams in June, October and January. So there's 3 exams per year, so there's plenty to use for practice. So I'd recommend anyone doing the linear to practice with the IALs as they're learning the topic, and then go and use the linear ones as full practice before the end of the year. Okay, so to start with, you need to know that voltage, EMF is a voltage, okay? So EMF is a voltage, and voltage is energy per unit charge, okay? They just want you to know which is the SI unit. Well, they've actually given it to you, so it's just volts. You don't even need to know the equation. So that's a very nice, easy question to start with. Question 2 then is about a filament lamp, which is a source of unpolarized light. So my students haven't done polarization yet, but what unpolarized light means the vibrations are in planes, so in all planes, not just in one plane. So it's not, for example, simplistic to think, it's not as simple as saying that the transverse disturbance is always up and down as the energy transfer is left to right. These vibrations of light are in all directions, okay? All planes. So then a polarizing filter is placed in between the lamp and the observer, okay? The filter is rotated in the plane perpendicular to the direction of the travel of light, okay? Which of the following is observed as the filter is rotated through an angle of 90 degrees, okay? So the light intensity does not change, it says. So only one filter they're talking about here. So light will be polarized, yeah? There's only one filter we're talking about. I think that could be the confusion. So light will be polarized whichever angle you put it through. So rotating it through 90 degrees will not change the intensity. It will just change the plane of polarization, okay? To make it change the intensity, you would need 2 filters at an angle towards each other. So the answer is C. The light intensity does not change, yeah? One Polaroid filter will just polarize it, okay? Rotating it. I mean, it will be less intense than not having a filter, because obviously it will block some light, but they're talking about the rotation through an angle. The rotation will just change the plane of polarization, not the intensity of the light going through. Okay, so here a guitar string is plucked, yeah, and a sound of constant frequency is heard, yeah. The wave produced on the vibrating string is what? So it's a stationary wave, so we just done that in class. So a stationary wave, a wave produced on a vibrating string, so it's a string that's vibrating, we're not talking about the sound. It's transverse, yeah, up and down motion, and is stationary. So it's because it has two fixed points at the end, and they're called nodes, yeah, and the string between the nodes vibrates up and down in phase, okay, and that's the first harmonic that it produces, okay. Which of the following has the largest de Broglie wavelength? So the de Broglie wavelength is the effective wavelength of an electron which behaves like a wave. So that's lambda, the de Broglie wavelength, which is Planck's constant h, yeah, divided by the momentum, which is mass times velocity. So electrons have wave-like properties. So today in class we were discussing the fact that light behaves both as photons, which are like particles in a way, or discrete packages of energy, and it also behaves like a wave. Well, the same, they found that electrons can exhibit wave-like properties as well, and of course we've always thought of electrons as particles. So, which of the following has the largest de Broglie wavelength? An electron traveling at 3 times 10 to the 6 meters per second. So remember that lambda will be inversely proportional to mass, okay? And lambda also is inversely proportional to velocity. So an electron is a small mass. So small mass will be a larger wavelength. So let's see the next one. So A looks like is the answer, but let's see why. Second one is electron traveling at 4 times 10 to the 5 meters per second. Yeah, so which one has the largest de Broglie? So you want lambda to go up, so you want m to go down. Okay, so m is down, and you see these ones are neutrons, much bigger mass, and the velocities are the same as A and B. So the neutron, because it has a larger mass, it won't be C and D. So the question is, will A or B have the larger wavelength? Well, the mass is the same, so the only difference is the velocity, and therefore lambda is inversely proportional to the velocity. So you want the smaller velocity to have the larger wavelength, okay? So obviously they both have the same mass, so when you're looking at this, you've got to realize that this is the deciding factor. Okay, so lambda is proportional to 1 over v, and obviously the v here is smaller than the v underneath it. And the smaller v will have the larger de Broglie wavelength. Okay? Okay, so back to the questions. Question 5. Which of the following graphs shows how current I varies with potential difference V for a negative temperature coefficient thermistor? So negative temperature coefficient thermistor means as the temperature goes up, the resistance will go down. So it's a negative temperature means it correlates negatively. So the graphs are voltage current. So as the voltage goes up in the first graph, the temperature will go up, yeah? And if the temperature goes up, because obviously voltage is joules per coulomb, so it's more energy given to the charge, then you're going to have the resistance going down. But this is a fixed resistance, so it won't be that one. Okay, so we're looking for, as the voltage going up, we want the resistance going down. So, and the gradient of an IV graph for lower R should be steeper, yeah? So the steeper it is, the lower the resistance will be. Because remember, voltage is on the x-axis. So higher V for this one will be a lower resistance, yeah? As it gets higher V, the steepness increases, so the resistance decreases. So the answer will be C. And you can see this one has infinite resistance, which wouldn't be correct, yeah? And this one has an increasing resistance. So you want a decreasing resistance with voltage. And the only one is C. I think I may have misspoken at some point in what I was saying. Okay, hopefully some of you will have noticed. I can't remember what I said though. Question 6, a string is stretched between two fixed points, yeah, and set into oscillation. So again, this oscillation sets up a stationary wave, and we're talking about a string, and they want to know the frequency of the vibrating string is not dependent on which, okay? So the equation for the speed is V equals square root of tension over the density of the string, yeah, the mass per unit length, and we know that V equals F lambda. They're asking about frequency, so we want to change V for F lambda, and then make F the subject of the formula. So F is 1 over 2L, square root of T over mu. So let's see which one, the frequency, which one does not depend on. The amplitude is not in the equation at all, so it won't depend on A. The length is in the equation, so it will depend on length. Mass per unit length is in the equation, so the frequency does depend on that. And the tension is in the equation, so the only one not in the equation is amplitude. Okay? So the amplitude is the giveaway. Okay? All right, so the next question is about an ultrasound transducer. So that means something that produces ultrasound. So here is the transducer. Is placed on the surface of a solid object as shown. So here's the surface of the solid object. A pulse of ultrasound is transmitted into the solid object. The pulse is received at the transducer 50 microseconds after it's emitted. Now remember, it's going to go down and then up. So those are the two arrows I've drawn. So because it's basically got an echo off the bottom of the block. And then the question's asking, which of the following can be used to calculate the speed of sound in this object? Well, it's basically distance over time, the speed, and the time, yeah, we want the time to reach the bottom of the block because the distance provided is 10 centimeters, okay? So once you know that's the equation you want to use, it has to go there and back. So the time is 50 microseconds. So here's the time given. So 50 microseconds means 10 to the minus 6. So because it's the time to go there and back. So for there, we need to change it to 25 microseconds. So it's 0.10, changing it into meters, divided by 25 microseconds, which is the answer B. That's 7 questions done. Question 8, the 2 copper wires, so they're both got the same N value of identical cross-sectional area, so A doesn't change, are placed in series, so that means the current is constant. Which of the following could be different for the 2 wires? Well, so it basically wants you to use this equation. Well, I is the same and N is the same because they're both copper. A is the same, they told us. Q, they're all electrons, is the same. Then the only thing that can vary is, well, V can't vary because if all those things are constant, then V must also be constant, otherwise they would not equal the same current. So since I, A, N, A, and Q are constant, V must also be constant to create the correct equation in the balance on the left-hand side and the right-hand side. So it can't be A, B, or C. So it has to be D because the voltage can vary with the length of the wires. Okay, and they haven't told us anything about the length. Okay, so the only thing that could vary, remember the answer is could, if the lengths are different, then the voltage across them would be different too. Okay. Question 9. The definitions for current and potential difference both include what? Well, they both include charge. One is charge per unit time and one is energy per unit charge. So that's a quick, easy question. 9. Question 10, the diagram shows the displacement, how displacement varies with distance along a stationary wave at 2 instants of time. Okay, so the dotted line is 1 instant of time and a solid line is the other instant of time. Okay, which of the following is not correct? Okay, so they always put not in bold to make sure you've read the question. Points X and Z are in antiphase. X and Z are in antiphase. Well, they're out of phase. That's correct. So they're out of phase. One is going, X is going up while Z is going down because they're in the opposite antinodes. So this is correct. We want to know what is not correct. Points Y and Z have the same amplitude. Points Y and Z have the same amplitude. Well, you can see Z will get a higher amplitude because it has bigger displacement because it's in the center of the antinode. So it will always oscillate with a larger displacement than Y. So that's incorrect. So the answer has to be B. But let's go through the C and D as well. For the sake of completion, points Y and Z have the same frequency of vibration. Points Y and Z, same frequency of vibration, yes, because they're going up and down together at the same rate. That's correct. And point Z is an antinode. That is correct because in between the nodes are here. And in between are antinodes. The center of the maximum displacement is the antinode. So that's correct. So the only incorrect one is D. So that's the first part of the video done. That's the multiple choice questions. If you found it useful, don't forget to show your appreciation. Give me a like on YouTube. Share it with anyone who you think will benefit from watching these videos. And make sure you subscribe so you know when the next video is going to be uploaded. Bye for now.